Hi, I'm Antoine Mottier, OW2, and thanks for joining me today for this talk about dependency management. In this session, I will introduce the FASTEN project, a service that can improve the way you are dealing with dependency management by making it more accurate. But first, I want to take a step back and try to highlight what is the current situation when you build a new project, how you deal with dependency management, what tools are already available, what are the limitations, and how FASTEN try to overcome those limitations. So first, when you start a new software project, you will probably not build it from the ground. You reuse libraries because they help you to create new software faster. You benefit from their stability, from all their features ready to be used, and hopefully you get a good documentation helping you to achieve your goal quicker. But this comes also with a set of challenges. The first one I want to illustrate is regarding what we call the transitive dependencies. Because usually in your application, you will use a build tool. For example, here during this presentation, I will focus on the Java ecosystem because I'm mostly familiar with Java. And so, for example, I will speak about Maven. Just for you to know, FASTEN also support Python and C, but I will focus on Java here. So when you create your Java project, for example, and build with Maven, you will declare your dependencies. And you might have, for example, 3 different dependencies here, A, B, and Z. And what you might not realize is that those dependencies have themselves dependencies, and the dependency of your dependency also have dependency, and so on. It's what we call the transitive dependencies. And so it's can start to build quite a large graph of dependency. You might end up with a large set of dependencies. And usually you will only care or manage your direct dependencies. But what if your code have a dependency and one of your direct dependency also have the same dependencies? If both depend on the same version of the library, in this example it's the dependency Z, if both your code and dependency B depend on the same version of library Z, it's okay, no problem. But if your application depends on version 2.0, for example, and your direct dependency depends on version 1.0, you got a conflict. And here, you can either try to fix that with some configuration that you provide to your build tool, or you can let your build tool decide what to do. But depending on the situation of your library, how the library evolved, for example, you might have some incompatibility in the API of the library. This might become an issue and your project build might fail. So it's always important to be aware of your dependency and the transitive dependency of your project. One key aspect I want to focus regarding this dependency is the security. Because you have control over your code quality and security of your code you are writing, but when you choose a library, you're relying on a third party to keep it up to date, secure. And of course, there will be some security issue in those libraries. So you need to update them. And you need to know when to update them and which library to update. And a lot of tools that exist out there will help you to do that for the direct dependencies, but not all of them will take care of transitive dependencies. And this is very important to cover all of them and not only the direct dependencies. Because, as I mentioned, the graph can be quite huge. It's now frequent to have projects with more than hundreds of libraries in them, so you cannot manage them manually. You need some tooling to help you identify which libraries need to be updated. Such tools here are, for example, dep clean, and I think it's a tool that is really useful when you start a project. It's like you don't want to include libraries that you actually don't use. So first step is, just limit the number of libraries. It's maybe obvious, but you have tools like depclean that can help you with that. But again, you need to be aware of some limitation, because it's kind of easy to be able to identify if a library is used, but being sure that the library is actually not used by your application, it's more difficult due to feature like dynamic loading of library. In Java, you have introspection feature that can actually call some library classes and methods, and there's no explicit call in your code. It's all dynamic at runtime. So for a tool like dependency, this is kind of a challenge to identify that the library is actually used. So sometimes you will have to actually double check the report from a tool like dependency to know what to do with one of your dependencies. Another tool that is quite useful and quite popular is Dependabot, integrated into GitHub, that will tell you and that the library needs to be updated due to a security vulnerability, and it will even create a pull request for you ready to be merged. That's very useful, but one of the important limitations of Dependabot is the last time I checked is that it will not deal with transitive dependencies. So we have nothing, no warning regarding security vulnerabilities in your transitive dependencies. On the other hand, Snake is able to do that. It will be able to identify security issue in your transitive dependencies. And finally, you can also use a Maven plugin, so directly embed this into your Maven build, so it will also run locally, not only in your continuous integration, but also locally on your computer. You can use dependency check Maven plugin to analyze your dependency and warn you and make the build failed if there is a known vulnerability in one of your dependencies. All those tools are great, but they have kind of important limitations. They lack some accuracy, because, for example, try to include a library in your project, but don't use it, and include a library with a non-security vulnerability. The tools like Dependabot or Snake will tell you that you need to update, whereas this should tell you that remove this library, or at least tell you nothing, but don't tell you to update it, because you are not impacted by the security vulnerability if you don't use it. And this is this accuracy, this lack of accuracy that FASTEN try to overcome. And how FASTEN do that is doing that by generating call graph for your application, and also for all the library available in public central repository. So for example, it will do that for all libraries available on Maven Central. It will generate a call graph to have an accurate view of how the functions are calling each other, and being able to identify if a given function is actually reachable from your project. And it will enrich this call graph with extra information, with metadata about, for example, security vulnerability. I also mentioned earlier, FASTEN is not limited to security. It's also cover license compliance, quality metrics, and so on. So it will enrich this call graph with all this information. And then by being able to identify if a path exists between your application and the vulnerable function, it will be able to tell you if an update is required or if an update is not required. This is very useful because it will reduce the noise for your development team and reduce the required update from your users. You will actually only update and release a new version of your project if you are impacted by this security vulnerability. If you include a vulnerable library, but you are not using the vulnerable part, it's okay. FASTEN will not warn you about it. It will only warn you in situation where the vulnerable code is explicitly called. So as I said, FASTEN get the information, get all the artifacts from central repository, enrich after generating the call graph, it will enrich it with various information such as security vulnerability, license information, code quality, and store all that in the FASTEN central repository. This repository is here for performance reason. It's a kind of cache for all public library available out there. This way, when you are running the FASTEN analysis on your project, FASTEN will need only to process your code and will get all the graph with metadata from the central FASTEN repository. So this boosts the performance of the overall analysis. So if we take an example here, if you have a project built with Maven with a set of dependencies, the first thing that FASTEN plugin will do when building your project is it will generate the call graph of your application. Then it look at the dependency of your application and communicate with FASTEN central repository to get the graph with all the metadata from the central repository. So you get all the graph of your dependency and then stitch all the graph together. So the graph of your application, the graph of all the dependency, be able to identify all the paths from the different function in your application in the libraries. And then it will be able to report you if you find a path between your application and one of the vulnerable code. Or the central repository here can be hosted locally in your company network, but it's kind of resource. It's required quite a lot of resources to be executed, so it's good to benefit from the central repository. So it's already almost the end of the presentation. We have very limited amount of time, but of course I will be able to answer questions. Just to mention before I finishing this presentation, the FASTEN project is developed by a consortium of several partners. You have the full list here, and it's an open source project. All source code is available on GitHub. You have also the website of the project. So don't hesitate to give it a try, provide feedbacks, report issue. We are quite open to any comments on the project. And if you want to start, I recommend to start with the Maven plugin. It's probably the most mature one, and it's quickly gives you a view of what FASTEN can bring to your project. Thanks a lot for your attention, and I welcome your question in the chat. Thank you.